Hello everyone. Today we are tackling multithreading in JavaScript, a topic that often trips up even experienced developers. While JavaScript is inherently single-threaded, there are ways to introduce concurrency and parallelism in your apps. We'll explore what that means, how it works, and why it is essential for building efficient apps. Stick around to the end for some advanced tips and tricks. Let's start with the basics. JavaScript is designed to be single-threaded, meaning it executes code one statement at a time. This design keeps things simple and predictable, but also means that JavaScript can only do one thing at a time. No true multitasking. In most programming environments, you can create multiple threads to perform different tasks simultaneously. But in JavaScript, everything runs on a single main thread, handling tasks sequentially. This single-threaded nature can cause issues when dealing with heavy computations or long-running tasks, potentially freezing the user interface and leading to a poor user experience. So if JavaScript is single-threaded, how does it handle multiple tasks like responding to user input, fetching data, and running animations all at the same time? This is where the event loop comes in. The event loop is a mechanism in JavaScript that allows it to perform non-blocking I/O operations by offloading tasks to the browser or Node.js environment. These environments manage tasks like HTTP requests, timers, and file I/O asynchronously, allowing JavaScript to continue executing other code while waiting for these tasks to complete. This gives the appearance of multitasking, but it is not true multitasking. Now, what if you need true parallelism, that is, running tasks on separate threads? That is where web workers come into play. Web workers let you run scripts in background threads, enabling parallel processing. When you create a web worker, it runs on its own thread, separate from the main thread. This means you can perform heavy computations in the background without freezing the UI. However, web workers operate in an isolated context, meaning they can't directly interact with the DOM. Their main use case is for the CPU intensive tasks like data processing, image manipulation, or complex algorithms. Let's see web workers in action with a practical example. We'll create a web worker to calculate the nth Fibonacci number. This is the perfect scenario because calculating large Fibonacci numbers can be computationally expensive. In our main script, we instantiate a web worker by pointing to worker.js. We send a message to the worker with post message, and when the worker completes the tasks, it sends the result back to us, which we handle in the on message event listener. In the worker script, we define a simple recursive function to calculate the Fibonacci number. When the worker receives a message, it computes the Fibonacci number and sends the result back to the main thread using post message. Web workers can do more than just basic computations. They support advanced features like shared workers, dedicated workers, and even WebAssembly integrations. Shared workers can be accessed by multiple scripts, even from different windows or iframes. This is useful when you need a single worker to handle tasks across different parts of your application. For even greater performance, you can use WebAssembly within web workers. WebAssembly allows you to run low-level code with near-native performance, and running it in a worker thread can massively boost your app's efficiency. Beyond web workers, JavaScript has other tools for managing concurrency. Let's take a look at a couple of them. Async await. Async await simplifies asynchronous code, making it easier to write and read. Although it is not true multithreading, it allows you to handle asynchronous operations in a way that feels synchronous, which can help avoid callback hell. Next is promises. Promises provide a way to handle asynchronous tasks that can be chained and managed easily. They work well for tasks that are dependent on the completion of previous tasks. Next is worker threads in Node.js. In the Node.js environment, you can use worker threads to achieve multi-threading. This is particularly useful for a CPU-intensive task in server-side applications. Before you dive into using web workers, here are some best practices to keep in mind. One, that passing large objects between main thread and worker can be slow. Using transferable objects like array buffers for more efficient data transfer. Always include error handling within your worker code to avoid crashes or unexpected behaviors. Only use workers for tasks that are truly CPU intensive. For more simple asynchronous tasks, stick with promises or async await. To sum it all up, while JavaScript is single-threaded by design, tools like web workers allow us to achieve true parallelism for heavy computations, ensuring that our application remains responsive and efficient. We also explored other concurrency tools like async await, promises, and worker threads in Node.js. If you enjoyed this deep dive into multi-threading in JavaScript, make sure to hit the like button and subscribe to my YouTube channel. Thanks for watching. See you in the next one.